Okay, we're going to go ahead and get started. Thank you for attending the BREEZE Risk Analyst Human Health and Ecological Risk Assessment Modeling System webinar. A couple of housekeeping items to go over. Please hold questions till the end, and also we will be recording the webinar and make that available sometime after on the website. Also, feel free to email questions. I have an email address at the end of the presentation where you can do that. And with that, we'll go ahead and get started. The content today is going to be a series of slides to provide some overview information, followed by a live demonstration. We'll go through some background of BREEZE, myself, some general introductions, go over some of the development objectives, discuss a general overview of the product, go through some of the detailed features. There'll be a discussion on the HRAP module, which is the first module that we've implemented in the software program, and then go into the live demo. Quick background, BREEZE has been developing software scientific computer models for about 26 years, specializing in air dispersion modeling. This is a new product for us. I've been working in the field of human health and ecological risk assessment for about 13 years. Quite a bit of work with US EPA developing a lot of the methodologies and tools that we'll be going over today and showing you, and also have quite a bit of experience with some of the other programs that are out there, which they're fairly numerous. There's no one standard, here in the US anyway, there's no one standard risk assessment methodology. There are various methodologies, guidance documents, depending on what program you're under. At some point we intend to implement additional ones. The first one that we've implemented in the software is the US EPA Human Health Risk Assessment Protocol. I'll be discussing that in detail a little bit more later. A general introduction, why are we interested in this product? What does this product do? This product is designed to do multimedia freight and transport modeling to assess how chemicals move through the different media, air, soil, surface water, sediment, and how those chemicals interact with different biological systems, including flora, fauna, human receptors. And then it takes that a step further and actually does the exposure modeling, which is to estimate how much of a chemical an individual is being exposed to and what the potential health effects of that exposure are. Development objectives. Why did we develop the software program? What are some of the main motivating factors for the development? We wanted a highly flexible GIS-based modeling system. I'm not going to read through all the details on this slide, but essentially we wanted it to have multimedia capabilities, multi-pathway capabilities, and by pathway I mean ingestion of fish, direct inhalation, other indirect pathways like fish ingestion, ingestion of animal products, pork, beef, milk, and the ability to analyze short-term and long-term health effects, including cancer risks, non-cancer hazards, and short-term acute effects. The system is really designed to be flexible to support the changing regulatory environments and be adaptable to other risk assessment methodologies or guidances that may be out there in the really across any and all programs. Again, provide the framework for assimilating multiple risk methodologies under a standard platform. There are a lot, as I mentioned earlier, a lot of different programs out there. These are several that are here in the U.S. We have TRIM, the HRAP, SLRAP is the screening level document, HARP is another program out of California. They're all different, but they share a lot of common functionality, or they have a lot of the same requirements. Most of the steps in the process are very similar. What's missing is a uniform platform to deploy and implement all those that provides users with the tools, both GIS features and database functionality in order to actually perform and implement these guidance documents. we wanted the software to support multiple air dispersion models. We did not want to limit this to any one model. We wanted it to support ISC, AirMod, CalPuff, SkiPuff, as long as these models are capable of producing the inputs in the correct units that are specified by the guidance document that the software implements. It has that flexibility to do that. Multiple air dispersion modeling output formats. If you're familiar with air dispersion modeling, there are numerous ways you can export data. There's different types of outputs. Even within those, there's different formats. So we wanted to provide the flexibility to import any and all those formats so that you weren't constrained, so that you didn't have to rerun your air modeling just to meet the specifications of this software. The third bullet, highly transparent. This one's incredibly important since these models, or this type of model, is different than air dispersion modeling in the sense that air dispersion models are typically developed and supported by the regulatory agencies. In the case of ISC and AirMod, for example, those are actual codes that were developed by the agencies to implement those methodologies. On the risk modeling side, we don't have that. We actually have to implement guidance documents and methodologies, which include equations and different equation inputs. We have to build our own models to do that. And because of that, the burden to eliminate this black box modeling is pretty high. So we've implemented a lot of functionality to allow you full transparency of all the equation inputs, the equations themselves, intermittent calculations, and then the results. I've discussed the scalable aspect, or one of the objectives. We're doing that by deploying different risk modules, and you've heard me discuss the HRAP module. That's the first one that we've implemented. I've briefly touched on multiple application formats. This initial product offering is an Esri extension or an Esri ArcView extension. There's future plans to deploy a standalone application, but the current version is deployed on top of an Esri platform. We also wanted the product to be flexible in the sense that it could support the objectives of different user communities, risk assessors, regulators, permit writers. There's a lot of different tools and capabilities within the software that sort of they allow the flexibility for each one of these different user groups to perform the tasks that they need to do their job. As I've mentioned, the product is an Esri ArcView extension. So the user interface visible on the screen here, this is ArcView. And the product sits on top of ArcView as an extension here. There's a blow-up of that on this part of the screen that shows you what tools are available there. This is really a format that's defined by Esri ArcView. That's how third-party software is deployed on top of their product. The main user interface for BREEZE Risk Analyst is this window here, this user interface. I'll go into detail and discuss that both in a series of slides and during the live demo. But 99% of the look and feel of the product is what you see in the lower right-hand corner. A more detailed view of the product. We've built the product on top of Microsoft's new ribbon bar, which lays out functional groups and tabbed content. And I'm not sure if you can read these individual tabs, but we have different tabs organized around the risk assessment process itself, and then we've placed all the different functionality groups within each one of those underneath that tab. So for the Sources tab, this is where you would do things like import air dispersion modeling data. You would assign or set emissions, chemical-specific emission rates, and do some other processing steps that are required. The Chemicals tab is what provides access to the underlying chemical database. This is where you have individual chemicals with all their numerous fate and transport and toxicity parameters. Moving to the next tab, the Site Characteristics tab, this is where you set different site-specific characteristics of your study area or project area. You can do things like define and select water bodies and watersheds, which are important for evaluating the indirect drinking water and fish exposure pathway. You can select and enter site-specific parameters specific to different categories, and these are fairly consistent with what's defined in the HRAP guidance document. There are quite a few specific parameters for evaluating dioxins and furans in breast milk, mercury. There are site-specific parameters, for example, rainfall, different soil characteristics that are used as inputs into the fate and transport and exposure equations. That's where all these things are managed and entered. The analysis tab at the bottom, this is where you actually set up your exposure scenarios and exposure pathways. The HRAP guidance document has a series of those that are defined for how you would go about doing this type of analysis. And we've implemented both the defaults that the HRAP document recommends and then also provided flexibility to customize those. And we'll go into that in detail during the demonstration. The final tab is the results tab. It's where you interact with the results of an analysis. You can query information, you can sort information. It's how you drill into your results to identify what the results show, identify what's driving the risk, which sources, which chemicals, which pathways. You have a lot of import-export functionality. There's some error logging capabilities. There's some validation functionality. Again, I'll show this in the demonstration. Features. The next several slides list quite a few detailed features of the product. I'm not going to read through each and all of these. This information is available on the website. Again, the modern Microsoft ribbon bar laid out with an intuitive process flow that follows the steps of the risk assessment process. We've implemented a really robust database engine that allows really efficient storage of data. This product can be deployed on individual source level or at the level of thousands, if not tens of thousands of emission sources with tens of thousands of receptor locations, hundreds of chemicals. It's very robust. You can do some fairly large-scale modeling. Again, very flexible import tools for importing different interdispersion modeling results and formats. We've provided a lot of comment-enabled functionality where you can put notes and comments and reference material depending on what parameters you've either changed from the default. It allows you to fully document what you're doing during the project setup and then on the reporting side. One important one to point out here, as an Esri ArcView extension, it's really an unprecedented base map format supported in the product. You're almost unlimited in what format you can ingest and manipulate. I won't go through a list of those, but it's the list of this from the Esri website is about maybe 30 or 40 pages long. Shape files, imagery formats, graphic formats, database formats, all of those can be directly imported and the software will interact with those. And I'll demonstrate how that's important later on in the process. Additional features, the guidance documents or methodologies that this tool is designed to perform, they're fairly complex. They have a lot of different parameters and descriptions, and it can be confusing depending on how the documents themselves lay out this information. It makes it difficult to track down which parameters are in which equation, why they're important, what the value is, what the reference is. These documents are typically scattered across a dozen chapters with detailed appendices. We've tried to, in the software product, allow you to get access to that information depending on where you are and what you have selected. You can pull up and look at the detailed descriptions of the parameters, reference information. It just makes it easier to understand the process. Again, if you go into a map production mode where you're trying to display results or build maps to do results communication, again, you're almost unlimited here in the aspect that that's really what Esri ArcView is designed to do. annotation tools, different map publications, formats, they're all supported. Mercury Wizard, there are several chemicals of interest that require special consideration depending on which guidance document you're discussing. In the case of the HRAP document, there are some specific requirements for mercury. We've provided the tools that automate that process, make it much more intuitive on what it is you're doing and what you need to do. One of the most time-consuming parts of the process when you're actually doing a risk assessment, a lot of times the identification and delineation of watersheds and water bodies for supporting indirect fish ingestion and drinking water, that can be fairly time-consuming. This product allows you to import, again, supported GIS formats such as the NHD database, the National Hydrography Database, which allows you to quickly identify and delineate all your watersheds and water bodies, and I'll show an example of that. Again, fully transparent results. There are quite a few analysis options. You can slice and dice the results any way you need to, depending on your objectives. You can look at individual emission sources. You can summarize results by source-specific, chemical-specific. You can do it into chemical groupings. You can summarize results based on exposure scenarios, really any and all combinations so that you can quickly identify where the problems are and what's driving those risks. There's a lot of map export options we discussed again. You can interact with GeoPDF formats. You can export to Google Earth. All these things help with results presentation, results communication. There's a lot of advanced statistical data analysis tools within ArcView itself and a lot of custom functionality. One of the final things that's useful in the product, if you're not a power user or don't have a lot of experience with ArcView, or you've already invested in expertise or tools outside of that product, you can export all results, all inputs, really any and everything that's calculated throughout the analysis into other formats that you may be more comfortable with: Microsoft Excel, Access, XML files, text files, HTML formats. All those can be exported for making it easier for you to work with whatever tool set you're comfortable with. Let's discuss specifically on the HRAP module. The HRAP guidance document is a US EPA document that was originally developed to support combustion permitting under RCRA. The guidance document was finalized in 2005 and the use of that document is growing significantly and fairly recently. It's taken a long time for people to get comfortable with the document, to use the document, and as that happens, as people gain more experience with it, both in the U.S. and internationally, you find that different states, different interest groups are starting to use the document more and more and use the document outside of its original intent. I think I have a slide that lists some of the examples of that. The guidance document includes the things that you need to actually implement a site-specific risk assessment. It has the risk assessment methodologies for how you go about selecting your chemicals. It discusses how you should perform air dispersion modeling to support the direct and indirect exposure pathways. It has detailed discussions on the exposure scenario and pathway selection. These are things like the farmer adult, the fisher adult, and then the different pathways that I listed earlier. It provides a series of fate, transport, and exposure equations, all the different inputs to those, both chemical-specific and site-specific. I would estimate over 90% of the parameter requirements for the equations are provided in the document as defaults. So we've provided the tools and capabilities where you can always revert back to and run defaults. Some of the parameters you do have to go out and collect yourself, and in many cases, because the guidance documents become outdated, you need to collect additional information or updated information, We've also provided the functionality to enter and modify any and all of those defaults so that you can keep things current with where things are, how the science is changing. The document includes the chemical database. There are over 400 chemicals listed in a companion database that they've developed. However, only about 204 of those have a full set of parameters required to run an analysis. This is a list of some of the areas where the guidance document is gaining a lot of exposure, being used more. It's actually referenced now in the Air Toxics Risk Assessment Library, which provides a sort of one-stop shop on what types of methodologies are available and how they can be used. So it's useful for doing cumulative or community-based risk assessments, site-specific risk assessments. That's a useful document to get some additional information. The document's been used a lot on toxic tort litigation. I've been involved in quite a few cases where we've applied that. It's been used quite a bit now in environmental impact statements, especially for coal combustion or coal-fired power plants, and it's getting into that process through NEPA or the EIS, Environmental Impact Statement. There's been quite a few of those here in the last 1 to 2 years. Environmental justice, residual risk, ecological risk. There is a companion document to the HRAP called the SLARAP, or the Screening Level Ecological Risk Assessment. That document is not used as much. What people typically do is run the HRAP module and then extract the media specific concentrations and run an ecological risk assessment. The guidance documents also, the odor nuisance has been used. I see the toxic torch listed twice there. Odor nuisance cases, it's used quite a bit to help demonstrate what the potential frequency of exposures can be. Again, this module does implement or fully implement the guidance document, listing some of the chemicals that are in here. The database contains over 400, although it's really unlimited. You can enter new chemicals and customize those. The chemicals that are included, especially the 204 that have all the parameters required to run an analysis, they include these groups that are listed here, your dioxins and furans, PAHs, PCBs, nitroaromatics, a lot of other organics, benzene, cumene, 1,3-butadiene, and then metals, mercury, lead, arsenic, chromium, hexavalent chromium. It's all the ones you would typically see in a human health and ecological setting. The exposure scenarios that are included in the guidance document are adult and child resident, adult and child fisher, and adult and child farmer. We'll go into some of the detailed pathways that are included in those when we go into the demo, but those are the recommended scenarios. You can customize those scenarios and sort of combine them in the software as well, so you can run in a default mode or a custom mode. A lot of times people need to evaluate the farmer, but also consider that the farmer ingests fish, so you can make those types of customizations to the defaults. Different pathways, we have the air, soil, surface water, and sediment. Vegetation, the forage silage, that's used to calculate ultimately the chemical concentration as it moves up through the food chain into the different animal tissues, pork, beef, milk, chickens. And then above and below ground produce for evaluating the exposure directly to human ingestion. The different animal tissues listed, pork, beef, milk, chickens, eggs, milk, and fish. And there's also a nursing infant or breast milk pathway specific for evaluating dioxins. We've actually added a pathway that's not typically considered in the HRAP, and that's the dermal pathway, mainly due to experience in performing risk assessments. A lot of regulatory agencies or different states, depending on the exposure setting, will ask for that pathway to be evaluated. It's not always directly applicable, but in many cases it can be, so we've also included that as well. And that follows the Superfund guidance documents. Source characterization. I wanted to real quickly touch on sort of the process of performing a human health risk assessment. This is very generalized, but it sort of sets the stage for moving into the live demo. You do source characterization. The input to the software, the input to human health risk assessment modeling is the results of air dispersion modeling. So that's always the first step, is you input information about the sources, including the location and the results from the air dispersion model. You couple that with emissions information, and then you look at the area surrounding the facility or your sources and collect site-specific parameters, things I discussed briefly earlier, different rainfall, erosivity rates, things that are needed for the fate and transport equations, exposure scenario identification, what exposure scenarios in the area make sense. Do you have farmers? Do you have fishers? Do you have residents? Do you have subsistence farming, subsistence fishing? All those things are important to characterize the exposure setting. Watershed, water body delineation. Once you've input all that information, you can start doing your analysis and results interpretation. And in a very simplified way, that's sort of the main steps of really any risk assessment process. And with that, we'll move into a live demonstration. As I mentioned earlier, the entire screen that you're looking at, this is ArcView. And the BREEZE Risk Analyst extension sits up here with a series of toolbars, the main one being the user interface. By clicking on that button, this opens up the UI that I discussed earlier with the ribbon bar format and the different tabbed content. And I'm going to walk through an example project that I have set up. This is a project in Jefferson County. I've changed the names of facilities and emission rates, but this is an area with a lot of heavy industry, industrial corridors where you have a lot of refineries, petrochemical manufacturers, that type of industry. And the first step in the process that we've gone through to set up this project, as I described earlier, is importing the air dispersion modeling data. And this area can get fairly complicated if you're not familiar with how to do air dispersion modeling to support both direct and indirect human health risk assessments. A lot of the terminology here and descriptions here is specific to the HRAP module. But what you see here, we have two sources that we've imported in this example. They're just labeled source 1 and source 2. Under each one of those sources, we have performed air dispersion modeling both on an annual basis and on a 1-hour basis to implement the different procedures or methodologies described in the HRAP document. And since we're doing direct and indirect or multi-pathway exposure, we have different phases that we're modeling or different chemical phases that we're interested in. So we've modeled with vapor phase, particle phase, and particle bound phase. And again, without going into the specifics on that, different chemicals behave differently in the atmosphere. Volatiles or vapors tend to stay that way. Particle and particle bound contaminants are typically heavier and at some point are deposited onto the different media, which is important when doing this type of analysis. So to describe a process real quickly on how this import is done and discuss some of the flexibility that's in the tool, essentially what we've done here is import plot files from ISE or AirMod. It really makes no difference. You point to where those files are, the software program imports those, and what you see here in the bottom pane is a visualization of what's in the plot file. And the next step is where you actually map, I would call it parameter mapping. You're mapping the parameters from the air model into the requirements of the HRAP guidance equations. And so simply by selecting one of these and selecting one of the columns, you're mapping the parameters by saying that for this run, my CYV parameter, which is the annual vapor phase concentration, you're simply pointing down here and looking at the plot file. This provides a good visual so that you don't make a mistake, and you can select that and it automatically updates the information here. And you repeat this process. It is somewhat tedious, but it's really the only way to directly map the results from an air dispersion model that have various formats and units into what's required by the HRAP methodology. The process looks tedious. After you've done it one time, you can store that information or those settings so that you can then apply that. Let's say you had 1,000 sources. Once you've defined all these different requirements once, that information can be stored and automatically used to import all the other source information. When that process is complete for all the different plot files, you run what's called the Create AMDB, which is the Air Modeling Database, and basically that just combines all that information into an index database that can be quickly analyzed or retrieved when you run an analysis. The results of that are it imports the receptor grid, which is the model, the locations that you actually modeled in the air dispersion model, and the sources, which show up here on the map. I will zoom into the project area so you can see all the different locations that were modeled in this analysis. And again, this follows a protocol methodology. I believe it's roughly 100-meter spacing out to 3 kilometers and then 500-meter spacing out to 10 kilometers. Again, that can vary depending on your application and what you're trying to do. So once that information is imported, I can move over and we'll briefly show the chemicals tab. Again, this is the list of all the chemicals that are contained in the protocol, and all their individual parameters are listed. They're grouped in the way that they're categorized in the protocol document. It makes it easier to access those since there's so many of them. But you can click on any of these and have full visibility on which parameters, what the values are for each parameter. And then again, there's information down here that describes what each one of these parameters are and units. The majority of the defaults are available. Again, it's limited to the set that's provided by the HRAP. You have full functionality to add new chemicals, delete chemicals. You can save chemical groupings. That can be important sometimes if you're evaluating, doing sensitivity analysis, evaluating different toxicity factors and what the effects of the risk are. You can put in, the same chemical 10 times with different biotransfer factors or toxicity parameters and do quick analysis on that. You have some tools over here to sort emissions or sort the chemicals to provide quicker access to those. The Site Characteristics tab, again, we've discussed these. It's where I make my settings on the watershed and water body and enter different site-specific parameters that are required. Here's a list of some of these. Again, a lot of this is the fate and transport properties associated with how chemicals move from both soil and vegetation into the different animal tissues or fish tissues, rainfall, erosivity rates, and then there's a series of parameters for the watershed and water body. Again, the tools within the program automatically calculate the area terms since this is a true GIS database. And in this example, I'll turn off a few things to kind of clean up the layers. We have a series of watersheds and water body information that was extracted. This shape is the full extent of the watershed, and I'll zoom in where we can see the water body in dark blue. This information was imported from an NHD data set and then used to make my selection on the air dispersion modeling data to either pick the maximum value or perform an average across that. That's again following methodology in the protocol document. So you move through a series of these tabs, making all these settings, filling in information where it's needed and where it's missing, and then ultimately moving to the analysis tab. Orientation on this tab, you're defining your settings. Which emission scenarios do you want to use? You might have multiple emissions databases where, again, you're looking at either sensitivity analysis or looking at the effects of different air pollution control technology, or looking at risk burn versus trial burns for the source of your emission rate. You can make a selection on that. You can select the HRAP defaults, or again, if you have user-defined defaults or you're changing that, your state may have different requirements. You may be applying this internationally, where the framework and all this applies, but the source of your input parameters is different, so you make your own changes there. And the standard scenarios are listed here. Again, these are the exposure scenarios. The custom tab allows me to select one and customize that, which I've done in this example. I've added a custom farmer with the addition of the fish ingestion. These are the exposure parameters associated with the custom scenario. So the custom farmer, these are the different inputs for the exposure setting. How much does this farmer ingest of all these different products that are listed? What are the exposure durations? Those things. And here you can see in the user interface the different pathways that are listed. If I've selected a custom scenario, I can go in and change these depending on what my analysis objectives are. I may want to only run inhalation, or in this case, I've selected all of them. I've run all the beef, or all the animal products, and also both water and fish ingestion. I've turned off acute and dermal for this analysis. To do the simplest analysis, the first thing you do is drill down into your project area. I'll zoom in here using ArcView tools, and any of these locations in red are, this is a DRG coverage in the background, but I know that that is a residential community. I have other information within the system that also helps verify that. Anything in this purple color, this is a land use land cover map, tells me that anything in this purple area is residential, so I can use the tool to actually make selections using the coverages that are within ArcView. So I can say, show me every location that's within a residential land use, and select that, and then run the scenarios that I have selected up here in my toolbar. But to do a quick one, I'll zoom in a little closer, and we'll use the imagery below, clean up the land cover information so you can see. So this is a color infrared aerial photo, and this whole area is obviously residential. I'm simply going to select one location to do an analysis. So I've selected one of these dots. These are the grid nodes that were imported during air dispersion modeling. I've made a selection on that, and that's where I'm going to apply my different exposure scenarios and pathways that I have selected. Oops. So review the settings real quick and go over to the Run Analysis tab. Again, getting to the transparency, there are several options here. The Optimize Run option doesn't really apply in this situation because I'm only running one location. However, if I had made the selection based on, let's say, the residential land use, there might be 1,000 grid nodes selected within that. And while you could run all those, typically you're interested in the maximum exposed individual within those areas. So if you select the Optimize Run, the program goes out and reads all the individual air modeling parameters and only runs those that would produce the maximum risk. So that's a useful option. It cuts down on the amount of data you have to deal with if you're not interested in looking at every single location. You can log equations. This is again where it shows individual equations from the HRAP document, all the individual inputs and intermittent calculations. And then you can also create a log validation, which is useful. It tells you when it tells you if the information is sufficient to complete an exposure scenario or pathway, and it goes down to an individual chemical level. So if, for example, you're running, I don't know, a chemical like acetone, and you get to the end of your results and don't have a cancer value and you're wondering why, you can go into that and look at the log, and it's going to identify information like that. It's going to tell you that it was missing a cancer slope factor, which is why that value wasn't calculated. So it's very useful for quickly understanding where you have data gaps and why you're missing certain information. For this analysis, I'll just put in a name. We'll give that a number and select Run. It's going to show the process for that. It ran that one location fairly quickly, and when you close that screen, you're automatically moved over to the Results tab. Some of the different levels of analysis that are available here, the first thing you're really interested in is what is my total risk at this location, my total cumulative risk. And so this is specific to the individual location I selected, and in this case I'm displaying cancer risk and hazard. My cancer risk is 1 times 10 to the minus 5, and my hazard is 1.7. As a risk assessor, that sort of tells me that there may be a potential problem in this area, and so you start to want to ask additional questions. Well, which source was that? Which chemical? Which pathway? That's what this toolbar up here allows you to do. You can click on those, and it's going to show the results at a higher level of resolution and add that information. So now we don't have a cumulative level, we have a cumulative level by source. And I can quickly identify by looking at that source 2 is the source that's actually causing my problem, or the source that's driving risk at that location. The next question of interest would be which chemical or pathway. If I select pathway, that is now displayed here. So I have for source 1, I have beef, chicken, all the different pathways that we ran. And I can rank those high to low. There's sorting tools. And when I look at that, I can quickly see that the water ingestion pathway appears to be what was driving risk for cancer. Both the water and fish combined are producing a number over the cancer target level. On the hazard, it looks like it's direct inhalation. So I have a couple of things going on here. Again, these tools are really useful if you're familiar with the risk assessment process. Select by chemical, and it's quickly going to pop up that information. I'll slide this over a little bit. Add a few columns so we can see what we need to. The concentration of the different media are provided in addition to the cancer risk and the hazard. In this particular case, though, it looks like acrolein is really the chemical of concern. That back. So again, you can now understand which source is causing the problem, which chemical is causing the problem, which pathway. That's very useful for going back in and then refining or making sure that your inputs to that make sense. On the risk assessment world, it's really critical to identify, which chemical-specific toxicity value is driving that risk. Some of those have higher confidences than others. This allows you to drill into that and get the information you need. This other tool is sort of how you get into some of the additional details. Show equations on click. Basically, by activating that, if I come up here and select any of these records with that tool, a user interface pops up that provides an extreme level of detail on what was used to calculate that value. So each one of the different equations that's in the protocol document is listed, the equation itself is listed, the individual input parameters are listed, and the result is listed. Basically, the software is self-validating. You can submit this, you can export these as Excel files, text files. You can import these results and provide that to the regulatory agency, which really provides your self-validation. It shows how these values were calculated. Again, I've stressed this many times, it's critical to do that in many cases because the agency doesn't have their own software that they can run the analysis through or standardized, like in air modeling, and verify that the numbers match what they get on their end. You can rearrange the analyses. You can delete analyses. A lot of times you're doing what-ifing, and you have a lot of analyses that you're not really interested in the results. You can get rid of those. You can export results, both the results that we were viewing here in the window. You can export those in multiple formats, text files, CSV files, Microsoft Excel 2007, XML. Quickly export those results, again, for doing post-analysis or different data analytics and utilizing the tools you're most familiar with. The log equation export, we can do that one real quick to show you what that looks like. So this will give you an idea of the level of detail that's available. When you actually export this information, you won't be able to see these, but it's every equation organized by exposure scenario and exposure pathway. So your inhalation, it's listed by source, by chemical, and it's a lot of information, but again, it's already in a spreadsheet format and fully supports both a transparent analysis and can serve as your validation test set when you submit anything to the agency. The error log can also be exported. Again, that just provides information on if something was missing, why it couldn't complete an analysis. A lot of times if you have 100 chemicals in here, you'll get results that at first don't make sense, and it's only when you start to drill into that you realize that the HRAP guidance document itself was missing certain parameters that are needed for calculating a certain pathway. And you can focus your resources or efforts on determining whether or not you need to collect those or not. And with that, we've really stepped through the process. It's coming up on 12:50. It's probably a good time to pause, open it up if there are any questions. There's a lot of different functionality that is built into here. Again, interacting with ArcView itself and mapping capabilities. One other thing that I'll pull up real quickly, one of the time-consuming parts of any risk assessment process is when you get to, once you've done your data analysis, you've analyzed the results, you can spend a lot of time producing figures for reports, preparing slides for risk communication, that type of thing. That's one of the huge benefits of having this in an ArcView extension. It's designed to do exactly this. I mean, it's designed to publish, map information and detailed attributes, and so this is just a quick example of a figure template that was thrown together that could be exported in multiple formats. Very useful, very powerful tool. With that, I'll pause and we can open it up if anyone has any questions at this time.
This is New York State. The question I have is importing AirMod output files. Are you limited to any particular, let's say limited to Trinity output files from their data software, or any
No.
output?
No, there is no limitation on that. The only limitation that you have to be aware of, the air modeling has to be created in such a way that the units and the output is what's required by the equations. So, for example, if you only did vapor phase air dispersion modeling, and you wouldn't be able to run the indirect exposure pathways, if that makes sense. So you have to sort of, if you implement the methodology in your air dispersion modeling, there are no limitations on the format that's ingested. One thing I didn't show here as well, there are some tools that allow you to, without getting into too many details, you can do unitized air dispersion modeling, which is typically what's done in a risk assessment. However, which allows you to, have one set of air dispersion modeling runs, and then you apply the chemical specific emission rate within this software tool to analyze individual chemicals. You can do that, of course, and that's actually the example I also provided. But you could also, within AirMod, for example, and really you're supposed to within AirMod, if you're doing deposition modeling, you should do chemical-specific deposition modeling. The program will also ingest that. Let's say you did mercury-specific modeling using AirMod. There's a selection option under the Sources tab that allows me to define what chemical affiliation this is. And so there is where I can say, okay, this isn't just a default or a unitized run. It is specific to mercury, which means your results are already mercury specific. And let's say they may already be in micrograms per cubic meter. So you can define that, and then you can also change and define the units of your modeling run. Again, that's helpful for making sure that your units ultimately are in the right unit to go into the equations. With ISE, for example, there's a limitation on how many significant digits you can store, and sometimes, like if you're modeling dioxins or something, you need to store your results in like a picogram. And you have to set it that way in the model, or your model is going to return zeros for all the results. So the modeler puts in a value that changes those units in the model, and this allows us to set that or recognize that that's what it is so it can do the correct conversion.
And this is Libby Henderson in Minnesota. I want to follow up on that. Did I understand that to mean that you could have one project that is mixed in terms of unitized air emission concentrations or air concentrations and pollutant-specific ones?
Yes.
Okay, thank you.
Any other questions?
I have one. This is Joan Tell from Merck. I was curious to see if you were going to implement the IUBK model for lead. It's often something that we have to run after we run HRAP.
Right. Luckily, that model's fairly simple. It's something we've discussed. It is not currently implemented, but I suspect that that one would be done. I mean, it's similar to what I would consider the next sort of smaller module after the dermal pathway. So I think so. Any other questions? If not, I want to personally thank everyone for attending today. Look for the website for a lot of additional information, and that's going to be updated frequently. We will also provide this webinar online for download for anyone that was unable to watch it or would like to look at it again.